Alright, so welcome back to another video, and in this one we'll be finally taking a look at the remote control car project. So of course adding Wi-Fi to it. So first of all, as you can see, this is a analog device. So we have our radio transmitter here in the form of a remote, and our car as a receiver. So what we're going to try to do is replace all the circuitry that's inside with this ESP8266 Wi-Fi module and this L293D motor controller. So we'll try to do that, and of course I'm choosing the whole dev kit one because it just works fine. I had no problems while flashing it, while programming it, whereas with the smaller ones I continuously had so many issues. It wouldn't program well enough and there were just tons of problems with it. So first of all, what I want to do is show you all how this actually works initially. And of course I have my tools here. We will be performing some soldering operations. So I'm going to use very commonly available cells. They are not alkaline or NiCDMH or um, nickel metal hydride or any of that stuff. These are just simple cheap cells that you get at a store, and I have actually done some modifications to the car itself, not in a big way, but there still are modifications. So 1, 2, 3 and 4. So yes, it does have neat flashing LEDs. So yes, the very simple LEDs, nothing much and to do, and this is for the uh, remote. So for some reason every remote in the world takes a 9 volt. Even my multimeter takes a 9 volt, and these batteries are like crap. They don't have any juice, they just have tons of voltage that no one really needs. I mean, they do get. So yes, that should work. Maybe it's dead. Was there supposed to be a switch? I did put in the right way, but yeah, so yeah, there it is. So it does work, and I'll just keep it on this pedestal. So yep, there we have it. So yes, you can see it does work, but the remote has gone a bit crusty, so it's not really working that well. So that's one of the reasons why I'm doing this. So the total voltage at the output would be around 6 volts, and I have chosen my controllers and other peripherals accordingly, and I'll tell you in a moment why. I'm just getting the batteries out of the way. Don't want to solder when they're inserted and have a huge explosion. So this has a tolerance voltage of 7 volts to power the IC as well as for the controls, and this has a V in, and it has an onboard voltage converter. So we have V in and we have a tolerance of around 9 volts, and it converts it automatically down to 3.3 volts for the whole system. And this does take up to around 2.5 volts as input voltages to control both the motors. So we should be pretty good. Of course, I really didn't check if it works that well, and if it doesn't work well at 3.3 volts, I might need to add voltage level shifters, which I do have to happen. And so let's go ahead and open this up and take a look what's inside. So this just has, I guess, 4 star screws, one. So even I don't remember how I actually did the modifications. Are the LEDs just connected to the 6 volts, or are they through something? I mean, they could possibly be connected to 6 volts because there is active components inside the LEDs to make them flicker. But let's see what I've done. Oops, so looks like one of the things are actually broken. Let's see if I can get it off. Yep, here it is. Can I get it off? It is stuck somewhere. There we go. Alright, so it's very crusty inside. It just doesn't feel good. So it seems that yes, the LEDs are connected directly, so I might be able to just take them off. Apart from that, a lot of analog stuff, of course, for the receiving end. I'll just go get a brush, maybe clean it off a bit, and then. So I was originally planning on removing all the wires from the motors and everything else, but it seems that the main back wheel drive motor has actually been tucked inside a casing, so I'm not going to open that up. Instead, I'll keep the same wire and hope I don't break it from the inside. So let's go ahead and open up as much as we can and take out this thing. Where's the other one? Or was it just one? It was just one. So off goes the antenna. We won't be needing that anymore. And there we have it. So what I'll do is take off the motor and also take out the wires from this motor, and I'll just keep these wires. I was hoping to replace them, but well, no harm, no foul. And then I will detach the main circuit from everything else. After that, I will end up with a few things. Apart from that, I will have 2 or 3 wires coming out of the positive end, 2 wires coming out of the negative end, and rest all the same. So let's get to it and let's have a montage time lapse. Alright, so if you're thinking what just happened, my camera just suddenly decided to stop recording for no apparent reason, and I lost a bit of footage. But not a lot was lost. You were seeing me in a time lapse wiring all the stuff. So just to catch up, what I've done is pretty much wired everything up. The uh, motor controller is wired to the battery terminals, and the Wi-Fi module is hooked up to the battery terminals and the motor controller pin out. So if you're thinking how I guessed out which pin goes where in terms of controlling the motors, this was pure guesswork. I've just set four pins, and I know how they are grouped together, and then I just managed to tweak out a bit of combination here and managed to get the motors spinning in the right direction. So I'll just show you how it works. Um, so let's go ahead and connect to the Wi-Fi of my controller, and once we are there we can, okay, so here's the image of the controller module, the controller page. So I hope you guys can see it's just four buttons, five buttons, forward, backward, left, right, and stop. So pressing the same button twice, I don't know if you guys can see. I'll share a screenshot. But pressing two buttons twice would make it, turn on and turn back on, and stop would stop everything that's happening right away. So just to show you guys how it works, pressing forward makes the motor move forward. Obviously, left makes it goes left, and right makes it goes right. Now I am experiencing a lot of power draw, so maybe these cheap cells aren't really made for this stuff. um okay, yeah, so maybe these cheap cells aren't really made for working in this circuit. So what I'll do is I really want to check what voltages I'm getting. Should be 6 volts, but I have a feeling that I'm not getting 6 volts, and I need a better battery. So these 1.2 volts battery would also work. They have a lot more current capacity, and then they also um, the motor controls will work fine with that. It has a minimum voltage of like 4.5 or something, and that should work. So I'll just get my multimeter and we'll see what voltages we are getting. So hoping that you can see my multimeter, I also speak out the voltages. I've sort of taped wires to my multimeter, so it just helps in probing. Um, so I'm getting a solid 5 volts instead of 6, a whole volt low. I'm guessing if I start moving just one of the motor, that will reduce it drastically to around 4 volts. That's what I think. Let's check. Yes, that's about 4.3 volts. Not ideal, but it's working. So I think we'll need to get some better batteries. So in my final test, maybe in the next video, probably I'll take it outside with better batteries. Also, I have to still decide on how to get everything inside. So what I was thinking is to keep the motor controller right there, and then to tape somehow the Wi-Fi module over at the top near the window, something like this. And what would that mean for us is should close and not interfere with much wires and stuff. I hope this is how it works. or we might not have enough clearance there. So the motor control with all the wires still too tall. That's a challenge. So we can start by actually sticking the motor controller down, and then I think we'll take the Wi-Fi module out to the top. Might have to do some soldering again, but should work. So montage, I guess. Alright, so this is what the final form looks like. I finally decided to put the Wi-Fi module outside. I really couldn't find much space. It is after all a very compact car. So I don't know where I might put it. I'm thinking somewhere like this should be sufficient, and if I really need to take it out, I can. I'll just put like a bit of Campton tape across or something like that to keep it in place. Just a temporary fix. So yeah, let's check it out, and maybe in my next video I will actually take it outside with the proper set of batteries. So I'll just let it roam around, powering it on. The MCU is powered on, and let's see how well we can do it. Alright, back on our thing. So you can see it's a bit slow, but again, yeah, the batteries, they don't work that well. Okay, and forward, and like I'm turning and I'm trying to move it forward, it won't, and now it will. So yes, very soon another video with proper set of batteries, and I'll be taking it probably outside, and I'll show you guys how it works. So I guess thanks so much for watching. I'll see you in the next one. Please like the video if you do like it. Stay subscribed, and I guess see you in the next one. Thanks for watching.